Hello everyone, welcome back to PMAC1114 trigonometry. So far we already finished section 5.1, 5.2, and the last video we talked about how to do trigonometry evaluation with special angle. We discussed a little bit about reference angle, quadrangle angle precision. Section 5.3 continue with trigonometry evaluation, but now we're gonna deal with the angle that is not special, and we'll be learning how to use a reference angle to evaluate the trigonometry value. Okay, so let's get started. Let's see how we're gonna do it. So I'm gonna put the topic today. I forgot to put this one in. Okay, so section 5.3. Okay, we continue with trigonometry evaluation. Okay, and in this video we also talk about cofunction identity. Cofunction identities also help us to evaluate trigonometry expression. However, cofunction identity is gonna later on it's gonna help you to do a lot of things, solving equation, trigonometry verification, a lot of things. But if you wanna use the reference angle, sometimes you don't have to use cofunction identity. Okay, so let's start with the reference angle one more time, because last time I give you to position a reference angle the first quadrant and the second quadrant, but now I'm going to give you the third one and fourth one, and we see the relationship between original angle and reference angle. Okay, so let's put here reference angle one more time. Okay, let's draw the picture. So the first case, I believe the first case we already talked about that. The reference angle is in the first quadrant. Okay. So there's an angle here. They should be overlapping each other, but sometimes it's very hard to draw the. Okay. So in this case, the reference angle, I'm going to call it theta prime. Reference angle theta prime. Last time I called it theta. It doesn't matter which one. Okay, but now if I call theta prime is the reference angle, then the original angle will be also theta. So theta prime and theta is in the same position in the first quadrant. Okay, so if it is in the first quadrant, sine, cosine, it should be the angle theta and angle theta prime should be the same. Okay, that's the first position. Quadrant number 1. Now the second position is quadrant number 2. Quadrant number 2. So the terminal side is on the second quadrant. So it's very hard to make it straight. Okay. So this is theta. It's the original one. You see the original terminal side on the second quadrant, and the theta prime is this one. Oh, I forgot to remind you one thing. The reference angle is always positive. Just put over here. I believe the last time I did not put it. So reference angle is always positive. So we don't have negative reference angle. Okay. So reference angle always positive. Okay. So in this case, you see that the theta prime and the theta is actually supplementary, right? Supplementary. So the sum will be 180 degrees. So I see that you can get a theta prime be from 180 minus theta. Well, theta is 180 minus theta. That is 180 minus theta prime. Okay. And the third position is when terminal sign in the third quadrant. Here, or here. Initial sign still here, but now terminal sign is this. So the theta is this one, and the theta prime is this. So the theta prime over here is actually 180 plus theta minus 180. So right. So there is theta minus 180. Okay. Or you can get theta, or theta will be theta prime 180 plus theta prime, right? So you see the relation between theta and theta prime. It's very important thing. I think I mess up with this. This should be theta. Okay. Okay. Now, and the last position is in the fourth quadrant. You must know this, okay? Because you don't know this, you don't know how to do trigonometry evaluation of a random angle. Okay, so the terminal side right here. So theta from here to here. That's theta. So theta prime is right here. Okay, so what's the relation between those things? The relation is theta is theta is 360 minus theta prime. Now think about it. If we go ahead and convert it to radian, 180 is pi, we learned last time. So 360 is 2 pi. So you can replace the 360, 180 with pi and 2 pi. So we can evaluate trigonometry expression in terms of radian. But right now, I already told you all the section up to 6 and 6.1, we still using degree, but when we start section 6.1, we're gonna learn radian. Okay. Okay. Now, so how we're gonna use this? I'm gonna give you an example, but because I want to, I don't know if I should. I guess we don't need to put this first Roman. I just put reference angle, and well, and the second thing I just put it cofunction identity instead of the first Roman, because the theory should be short. Most of the time we focus on example. So cofunction identity here. So the cofunction identity is the relation between two angle but related to 90 degrees. So basically they are kind of complementary to each other. And this is how it goes. This is how it goes. If you have sine of pi over 2 minus theta, then it gives you cosine theta. So the relation between sine and cosine associated with each other in 90 degree. Cosine of pi over 2 minus theta will be sine theta. Okay, and tangent pi over 2 minus theta will be cotangent theta. Okay, so if you go ahead and draw the picture, it is, of course, it must be in the first quadrant. It must be something like this. Y-axis here. Theta right here. Okay. So pi over 2 minus theta is actually this one, right? So pi over 2 minus theta, I'm gonna call that no, I'm gonna go ahead and call it whatever you want to. I'm gonna call it alpha. So pi over 2 is 90 degrees minus theta. So this is alpha right here. And it makes sense because think about it. This is right triangle. And this is also right triangle. And sine of this angle. Okay. Cosine of this, cosine of theta, cosine opposite over hypotenuse. Okay. And this is equal to sine of this one. Cosine is adjacent. Cosine adjacent over hypotenuse is the same as sine opposite over hypotenuse, because the opposite over here for this triangle and the adjacent of this triangle, they are the same because this is rectangle. Okay, so sine of alpha is opposite over hypotenuse is the same as cosine adjacent to hypotenuse. It's the same. It's the same. So yeah, alpha and theta, they are complementary to each other. So the sum is 90 degrees. Okay. Really helpful identity too. So try to memorize it. Okay. And let's say I'm gonna give you some example. But before doing that, let's say we're gonna use reference angle to find the exact value for each trigonometry. Okay. Ratio or trigonometry's value. Example number 1. Okay. Find cosine negative 240 degree. You know 240 degrees is not special, right? So because it's not special, we cannot get the output right away. So this is the input. It's a function input, so we need to find output. That's what I ask you. So the output must be the value. The input is always degree or radian. So far we just learned degree. Okay, so in order to do this, very easy. Okay, but you need to get used to it. Even though it's easy, you need to get used to it. So you draw the reference angle. Okay, and you know that this one going clockwise because it's negative. So we know the whole thing is 360, so 240 is not the whole thing yet. It's not the whole revolution yet. So it's about, we take 360 minus 240. So let's see how much it go. It go around up to, we have left 120 because you take 360, you add to 120, you subtract by 120, you give you 240. So it's gonna be like this, guys. So 240. So there's 180 already. So you need how many more to get 240? So 180 minus 240, you need 60 more. Okay, so you need 60 more. So your, think about that. This is 180. So 3, 30, 90, 30, 60, 90, right? Each quadrant you can divide into 3 parts. So each of them could be 30 to make it 90. So you want 60 more. I mean, you need 2 more parts of the 90. So here, so 30, so right here. Okay, so that is your negative 240. Okay, so that's your theta. So then what is theta prime? Theta prime right over here. Theta prime is positive. Okay, so this is theta prime. Okay, so we're gonna go ahead and use theta prime to calculate the theta. So how we do it? So cosine. So now that cosine of negative 240 is the same as the second quadrant. So second quadrant, the cosine could be negative, so it could be negative cosine of the theta prime. And the theta prime is what? Negative cosine of, just told you this 60, right? Okay, and cosine 60, what to give you? Cosine 60 is sine 30 because that's cofunction identity, or you can go ahead and memorize the table we learned last time. Cosine 60, go back here. Where? Cosine 60 right here. Cosine 60, 1 over 2. Okay? 1 over 2. So I'll give you cosine negative 1 over 2. So the answer is negative 1 over 2 is the output. Okay? So you draw the picture, you draw the reference angle, you draw the picture, you figure out reference and everything will be easy. Okay? And as I just want to add that you don't need to, but it's for clear explanation. You can put this as negative sine, right? Pi over 2 minus 30. You can write like that if you want to. So it's actually to give you the same thing, but this is redundant. You don't need to. So you get this, then you can jump to this. Okay? And how about this one? This one a little bit bigger. Tangent 675. Okay. Okay, 675 is much bigger than 360, so we need to see like how many revolution out of 675. So you take 675 minus 360, what to give you? 315. But 315 is not a whole revolution, right? So it looks like when you draw it, you have to draw at least one revolution first. Okay, that's why. So you draw at least one revolution first with 360. There you go, one revolution. Then you need to add a 315 more. So bigger than 180. So you subtract with 180. Let's see how many more. 135. Okay. So 350, or you can do like 360 minus 315. Oh, so 45. So it looks like you almost do another revolution, but we stop at 45 degrees. left. So the reference terminal side right over here. Okay. Sorry, I forgot to draw it. There you go. Right here. So this must be theta prime, 45 degree. This is 60 degree. Okay, so this. All right. Yeah, right. Because 360 plus, because that's 45, so 360 minus 360 minus 45, 360 minus 45 is 315. 315 plus 360 give you 675. So theta prime over here. So it is a 4 quadrant, so we can calculate the tangent of 675. In this quadrant, tangent will be negative, right? Because this is quadrant number 4. Go back. You forgot. Tangent quadrant 4 negative. See that? So this one will be give you negative tangent what? Tangent 45. Because tangent of theta prime. So tangent 45 give you 1. So the answer is negative 1. Easy. See that? You draw this, you can solve it easily. Yeah? Okay. Now, let's do another one. So, let's make it an expression. Let's see. Example number 3. Let's see, I have this one. Cosine 7 cosine. Evaluate. This is a whole trigonometry expression right here. It's not a trigonometric arithmetic. Evaluate cosine 780 degree plus 2 sine square 60 minus tangent square 30. Well, this part easy because sine 60 square root 3 over 2. We already learned that. Tangent 30 is square root of 3 over 3. I forgot. You can go back here. Tangent 30. See, square root of 3 over 3. Okay. Very easy. Just memorize it. So square root of 3 over 3, sine 60 square root of 3 over 2. So this one looks like we just need to calculate this one. This is the hypothesis 780. It's not special. So this is square root of 3 over 2 square. And this square root of 3 over 3 square. Okay. Now we're going to calculate this. Of course, we're going to use reference angle. So we'll go ahead and draw the picture. Okay, we need to figure out how many revolution in 780. So that's 780 minus 360 minus another 360. Give you 60. Look like 2 revolution positive and 60 degrees. So 1 revolution, 2 revolution, and another 60 degree. Okay. So another 60 degree. So theta prime right here. Oh, I forgot. I need to draw. We need 2 revolution. Let me do calculation again. A minus 360 minus 360. 2 revolution and 60 degrees. So hate it. So right here, that is the theta. That is 780. So the theta prime will be this one. The theta prime will be 60 degree. So cosine of 780, it will be cosine, because it's first quadrant, cosine positive, cosine 60. And cosine 60 give you what? 1/2. So right here, I can evaluate it. I'm going to call this A, okay? So A equal to 1/2 plus 2 square root of 3/2 square minus square root of 3/3 square, which is give you 1/2. 2 times 3/4 minus 3/9. So the answer will be 1/2 plus 3/2 minus 1/2, because simplify this, so the answer will be 3/2. 3/2. Right, we can cancel this. Okay, so you see that if you can evaluate individual trigonometry function of the non-special angle, then you can evaluate the whole arithmetic expression of trigonometry arithmetic expression. So easily, right, using reference angle. So as long as you understand the reference angle, okay, this picture, you always have to draw this, then the evaluation part will be easy. Okay, so that's all for section 5.3. Should be very short. If you have any question, please let me know. You gotta practice, guys. This kind of thing you gotta practice. So even though that the course does not require textbook, I still recommend you to go to the go eBay, just buy some used book. Okay, you don't have to pay like $300, just maybe $100 or $150 less. Try to get the textbook, trigonometry textbook or pre-calculus. It doesn't even have to be exactly the same textbook that we are using. To try to get some used textbook, very cheap, guy. In eBay, sometimes pre-calculus textbook only $10. Of course, the new one could be probably cost you $50, $100. But you can get afford the good one, clean one, because actually $3-4, $6 is kind of old, and there's some shop they offer the brand new but never touched, kind of old but it's still brand new. But I recommend you to buy it. Usually nowadays, professor don't recommend students to buy textbook, but I don't know. Probably I'm not an old guy, but it looks like I'm an old guy. But I'm not using the digital version of any textbook. Buy the old textbook. They're cheap. You can practice on this thing. And if you have question on that textbook, and you can ask me like which problem in the textbook you can practice, just you can visit my office. Okay, visit my office. Or you just go ahead and take a picture of that and put it on canvas and let me know which problem you can do. Go ahead and do it. Okay. All right, that's it for the video. I'll be seeing you next time for the new section.